Hello, everyone. On behalf of IBM Systems Magazine, I'd like to welcome you to our presentation. My name is Janine Donnelly. I'm the manager of webinars for IBM Systems Magazine, and I will be the moderator for today's event. We will be holding a Q&A session at the end of the webinar. You may ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources. You'll find that on the left side of your screen. And you can download the deck right from the platform without being disconnected from the webinar. Today's webinar, Managing Your Mainframe Perfect Storm, is sponsored by BMC Software. Our featured speaker today is Jay Lipovich. Jay is Senior Manager of Solutions Enablement for BMC Software's Z Solutions. His focus is on mainframe systems management, MLC cost optimization, and capacity management strategy and solutions. Today, Jay will share tips and tricks that you can use to help you optimize your mainframe capacity for maximum cost control. So without further ado, Jay, I'll turn the presentation over to you.
Thank you, Janine. Welcome, everyone. Thank you for joining us. We're excited to share some ideas about the mainframe, a platform that, quite honestly, continues to amaze the world. When you think about the capabilities that are available with the mainframe, especially with the introduction of pervasive encryption, the concept of having all of your data solidly protected and encrypted just makes you wonder why anyone would think of another platform. And for all the strength of the mainframe, we've got a few challenges. And so that's what I wanted to spend some time here discussing, is the whole issue of managing capacity and costs and what we have to do to deal with the changes that are affecting the way we run mainframes and what our businesses expect us to do. I'd actually like to start with a reminder of a quote from the IT management guru, Peter Drucker. Peter Drucker said, "Long-range planning is not concerned with future decisions, but with the future of present ones." And in a nutshell, the goal of mainframe capacity management is to have the information to be able to make current decisions to ensure the success of the organization in the future. So I'd like to share some ideas about what I'm characterizing as the perfect storm, and then some ideas about what we should do to be able to adapt and accommodate those changes. Let's start with a level set. You know, capacity management's a balancing act. If we operate over to the left side of this diagram, we have sufficient capacity. But if we over-provision for the environment, we increase the capital expenditure and the operational expenditures that we might incur. Operating on the other side of the curve, to the right, if we don't have sufficient capacity, we can miss service level agreements, we can lose revenue and perhaps reputation damage to the organization. And with compliance and regulations changing so rapidly, we actually can face financial penalties as well. So managing this balancing act is what we've done for years. Capacity management on the mainframe has been, I would propose that it's been a well understood effort, and we've had a pretty good idea of how to do it. So this perfect storm, though, of three elements is going to make us take a new look, perhaps, at how we do things. So digital disruption, cost optimization options, and what we'll call the brain drain. So let's drill into those just a little bit more with some data. So you are getting an opportunity to see an advanced peek at data from the 2018 mainframe survey that BMC conducts. This is our 13th year. We have over 1,000 respondents, and we ask them what they're doing with the mainframe and what their thoughts are. And one of the areas we focused on is change, and even more importantly, the rate of change. So what we have here are three of the questions we asked. The first question is on the far left side, is the data volume and how has that changed? And the green bars are increased. So you look at that number and you say, well, it went from 51% to 55% of respondents saying data volume is increasing. And then in the middle, we asked about the number of databases, which increased from 38% to 45%. And that arrow, that up arrow you see, means we do statistical significance testing on all of the data. That is a statistically significant change year over year. So more people are saying that the number of databases is increasing. And on the right-hand side, we're looking at the transaction volume. And once again, the increase from 52% say it's increasing to 59% say it's increasing was a statistically significant change. Now, two other questions we ask are particularly important for capacity management. One is the speed of application change. Now, on the surface, this change went from 45% to 46%. And you say, well, okay, is that really any change at all? Underneath the data, we also asked, what is the rate of change? And one of the options was more than 25%. And those responding that application changes had increased more than 25% increased year over year by several percentage points. So while change continues at a fairly steady pace, the rate of change seems to be accelerating. And finally, maybe the most important one for capacity management is this question. It was about workload volatility and unpredictability, where again, a statistically significant change from 46 to 51% saying the volatility and unpredictability is increasing. So what all this means if we're doing capacity management is this. You know, the business demand that we understand is changing, and we almost might look at it and say, we don't know what we used to know. I was at Share earlier this week and speaking with one of the attendees at the conference, and we were talking about this concept of what don't we know that we used to know. And he said, you know, we used to know that the morning peak was at 10:30, the afternoon peak was at 2:30, there was a little drop at lunch, so we could graph the McDonald's curve and know how our system's demand was flowing. But with the digital disruption, and you look at the data that we've just looked at from our survey, the demand curve has become much more volatile. And this creates a band of uncertainty, and capacity management has to be able to accommodate that. I'm going to pause for a question. There's a question that says, do the majority of millennials hate JCL and ZOS, or do they just have no interest? I can't speak for the majority of millennials, but I would invite you to join our IBM Systems Magazine webinar on September 19th, where we will be sharing more of the information from the survey. I can tell you this, those responding to the survey, we captured demographic information, and the younger respondents are more positive about the mainframe than the older respondents. So it doesn't directly answer your question about do they hate JCL, but it does suggest that the new workforce is injecting enthusiasm and interest into the mainframe. And it's a good thing that you asked that question, because the skills gap is one of the challenges that people are worrying about. This first data point is from the Society of Information Management 2017 Trends Study. And these are the responses of the senior IT executive at 801 organizations. And their number 3 most personally worrisome issue is staffing, training, development, and retention. I can tell you that their number 1 concern was security, and their number 2 concern was recovery and resilience. So before cloud, before new technologies, before anything else, came staffing for their concerns. We also have information from an analyst who said that 75% of enterprises will experience a visible business disruption due to IT skills gaps by 2020. That's 18 months away. So we have to ask the question, if this is 2018 and there's a potential event on the horizon, is your capacity planning ready? And that's kind of the focus we want to talk about. When you consider the volume increase, the velocity or the rate of change increase, and the unpredictability or volatility, all of those pressures are making it even more difficult for IT to operate and especially to plan. And then you throw in all of the new things you have to concern yourself with, from hybrid multi-clouds to security to all of the Internet of Things, and everybody trying to touch your systems all the time, every day, it becomes a bit of a challenge. So what I'd like to do is ask a polling question. Let's see what the attendees say. How do you rate your capacity planning readiness to handle these issues? You've got these 5 choices. At a level 5, we're ready to handle whatever comes our way. Mostly ready, but you may hit a rough spot. We'll likely experience some disruption. We're behind the curve and we need to make adjustments, or I'm not sure where we are. So at this point, Janine, if you want to open the survey to the attendees.
Great, Jay. So they should have the survey. Please select your answer and hit submit. And then we will be sharing the results of the survey back with you. So I want to give it a couple more seconds, Jay. Go ahead.
Okay. I quoted Peter Drucker earlier. There's one other IT guru who said something that is particularly important in the way we look at capacity management. His name was Richard Nolan. He was writing in Harvard Business Review, and he said, the good manager, and I'm going to expand that, a manager could be everything from an IT manager to the person managing the capacity planning effort for the organization. The good manager should not think of data processing as a technical sandbox in which to play, but as a resource which enables the company to earn a greater profit.
Okay, Jay, I'm going to go ahead and send these results out to our audience.
Okay. So you all should be able to see the results. Thank you all for responding. A little over half said we're mostly ready, but we may hit a rough spot. And so we'll talk about what some of those rough spots might be. But then at the bottom end of that, we've got about 40% that may want to look at some ideas about how to change some of the processes or some of the information to be able to manage the storm issues. And that's what I'd like to share. Here's some ideas. 12 steps, if you will, to calmer seas for the perfect storm. And I'll highlight these, and then I'd like to look at some examples of some of the key activities and actions you could take. So first, addressing digital disruption, try to align your business application understanding into the planning and reporting process. Number 2, recognize what is disruptive change versus noise. 3, Because of the rate of change, we need to be ready to rapidly evaluate the impacts of changes and the alternatives we might be able to use, and use sensitivity analysis to help you manage uncertainty. Because the fact is, the world's changing. We can't eliminate the uncertainty. We just have to come up with a better way to manage it. Now, if we look at all of the options that are available, the fact is the number of options for how you configure not only the hardware but also the software is growing, and they're more complex. And so it's a complex process to try to figure out what is the balance of hardware decision, software decision that lets the business meet its organizational goals. So rationalizing hardware costs versus performance. We'll assume at the end of the day that the goal is to deliver a defined level of service for business-critical customer-facing applications. And again, customer-facing could be external customers, or in some cases, you may have critical applications for your internal customers. You need to be able to evaluate and choose the best software cost options. For example, software containing options. And we'll take a look at some of these things in more detail. The volatility that we experience and that we see can be addressed with scenario planning, where you can rapidly look at some alternatives and eliminate the ones that don't make sense quickly. And then you have to be able to support a wider range of what if this happens, or what if we did this, to enable your organization to make decisions. Now, I'll pause for a minute with this concept of capacity planning and decisions. Capacity planning looks at the capacity of the system and its ability to deliver the service required by the organization at a cost that aligns with the organization's goals and priorities. Many times, you end up in a situation where there are alternative courses of action, and it may not be clear which one is best, because the decision is really a business decision, not a capacity decision. So we'll look at an example in a little bit. But as capacity planners, there are times when the goal is to present the alternatives in such a way that the alternatives depend on a business decision. For example, what forecast are we going to accept as the planning forecast? Who believes forecast 1 versus 2 versus 3? That's a business decision. Capacity planning simply tries to lay out what would the results look like under all 3 forecasts, and then tells the business, if you accept one forecast, here's what you can expect in terms of capacity requirements and service delivery. If you accept another forecast, we're going to require, let's say, an upgrade 6 months earlier. Now, at that point, it is not a capacity decision, it's a business decision. And so you want to be able to get to the point of clarifying capacity decisions that are dependent on what the business decides. And finally, looking at the skills issue, we've been doing capacity management in the mainframe for years. I believe, personally, it is one of the most well executed strategies. Depending on who you talk to, they have various implementations of capacity planning tools and methodologies. But the mainframe, on the mainframe environment, we know how to do capacity planning. The challenge is that in most of those cases, the ability to deliver that capacity planning has been tied to the skills and knowledge and craft, if you will, of the capacity planner. And many of those people have decided they're going to retire, they're going to move into management, they're going to go do something else totally different with their lives. And so we have to be able to replace that. So solutions can help, where they have engineered in some of the SME knowledge that these technical experts already have and have been providing. Automation, because of the rate of change, is kind of an absolute. And so automate, automate, automate couldn't be stated strongly enough. A lot of approaches have used SAS programming, for example. And when the skills go, the ability to understand that and to execute that and the time to do it is changing. So to the degree that we can eliminate programming and focus on making decisions, that helps the brain drain. And finally, because of the rate of change combined with knowledgeable people leaving the organization, we can gain insights into what's going on with machine learning. And using machine learning and analytics, we can let the system tell us what's changing and where it's changing and help us to make better decisions. So let me touch on just some of the, what I'll call the storm-proof requirements, and drill into what you can do to up-level your capacity planning efforts. And these are the 6 that I'd like to touch on, and I'll show you some examples. As I said, we'll go fairly quickly through this information. If you have questions, share those. If we're not able to get to them, we'll be happy to get back to you to discuss them in more detail. Let's begin with what I believe, if you were to do just one thing in your capacity planning efforts, this is the one thing you could do that would improve the value of capacity management in your organization. And that is to get aligned with business applications or business services. So let's take this example. It's a banking service. It's an online loan application. So transactions come in. They come into a KICS region. They go off and they get spawned an MRO. They hop over to grab some DB2 data. They use MQ. If they've got Java, they may be running Liberty and do some Java work, and then that's using some USS. And traditional capacity planning tends to look at what's the growth in KICS, what's the growth in DB2, what's the growth in MQ and on the system and so on. When you do that, it's difficult for the business to understand how the capacity plan aligns with what they're trying to accomplish. So the approach is to represent those groupings of transactions and or jobs that represent the business service. Now, if we're able to do this, we get pictures like this. On the left-hand side is utilization expressed in MIPS, kind of a common metric. It's the utilization for online loans. And it specifically shows the breakdown of how much of that usage came in DB2, how much in KICS, and how much in MQ. So now we're not only able to answer the question of what's going on to the business. We say your business service is consuming this much of our system, and it's spread across some different technologies. But when we also start looking at the performance implications, we look at the response time, we get to see a similar breakdown. So the total response time for online loans on the mainframe was this, broken down by KICS, DB2, and MQ. And maybe surprisingly, for people who would say, well, there's a lot of DB2 usage on that. If there are problems, it's probably with DB2. Well, except in this case, their big delay wasn't with DB2 at all. It was with MQ. Having that view of the business application and the technology under it lets us relate to the business owners and lets us couch the plan in business terms. So by that, take this example. This is just creating a capacity plan, and there's a growth over 3 quarters. But instead of growing KICS and DB2 and MQ, I grow a specific application. Now in this case, the KICS MW application is a group of transactions. This is supporting a manufacturing company. And so we can apply growth and say we expect this much growth over these growth periods. And below the covers, we know that what has to happen is all of the technologies that support that need to be grown by some amount. And by having the application understanding to start with, we can simply say, let's grow the application, and we will see appropriate levels of growth in DB2, in KICS, in IMS, and MQ, and whatever technologies are underlying it. So I'll repeat again, at the risk of being obvious, if there's one thing you could do to raise the value of capacity planning, it would be to start aligning your reporting and your planning directly with the critical business services in your organization. Now, the volatility that's introduced by digital engagement is one of the troubling problems for a capacity planning effort. We're used to getting forecasts and working with a pretty solid forecast, plus or minus a little. But volatility raises the question of, what's normal and what's not normal. And then when I'm trying to analyze historical data to determine the cause of a recurring problem, understanding what's normal is even more critical. But because my underlying fundamentals are changing so rapidly, what I used to know was true is not true anymore, perhaps. So we use machine learning to capture the data, the recent data, and tell us what's normal, because I don't have the time to figure that out on my own anymore. So here's an example. This is online loans. We're looking at response time for a day. Kind of the first thing that jumps out is 3 o'clock hour, and you say, is that an anomaly? And we don't know. So a traditional approach is to use averages and create a threshold. So here we have the static threshold that was created with averages. Well, that's telling us that 8 o'clock, 9 o'clock, and 11 o'clock in the morning have a little bit of a problem, and 3 o'clock is a real problem. But if we use machine learning and we do analytics on the history data, it can analyze and calculate what's normal. And in this case, we've calculated a high value and a low value of what's normal variation for this metric for these hours. And as you can see, it turns out that none of those is out of normal. Now, 3 o'clock is pushing pretty close. So we would start to get predictive on what's going on in the 3 o'clock hour. But looking at just the data as it stands, nothing's out of normal. With an approach of a static threshold, we might have been raising alarms. With this kind of view, we know that we don't have to raise alarms, but being proactive, we would look at the 3 o'clock hour and we would start to project what might happen if that becomes the new norm. As I mentioned, the variety of options we have available are changing fairly rapidly. So when we start to say what's going to happen, we ask a what if question. And the types of questions are fairly lengthy. I tried to encapsulate them into this list. So obviously, we have applications that grow or decline. We may have new workloads come on that might resemble an existing one or that might not resemble an existing one. We may have the option to move workloads around. We're letting Workload Manager do a lot of workload balancing, if you will, but there may be times when moving workloads makes sense for either a capacity or a cost decision. The hardware options continue to be focused on the processors, the specialty processors, the number of engines, the individual DASD devices, the tape, and what's going on in the interaction of all of those with the way the particular workloads use those resources. One of the ways for managing capacity without necessarily spending additional capital is to look at hardware reconfiguration options. I've got a certain number of engines assigned to the LPARs. What if I change that? Well, what if I change and add zips? Do I have latent zip capacity that could benefit, or zip work, sorry, that could benefit from additional capacity? What if I reconfigure an LPAR or some of the devices that I've hung out there? Then what about some software pricing options, like container pricing or mobile pricing? And we'll look at an example dealing with container pricing in just a bit. We noted that application changes seem to be accelerating. So one of the questions capacity management can answer is, what is the impact of application changes? I've seen this operate so many different times in different ways. In one case, a company was considering a new application focused on their agents, and they developed the application and did a pilot. And they estimated that the application was going to require, it was kind of a thumb in the air, going to require about this much to run. The capacity team started capturing the data when they were running the application in the pilot, and then they modeled what happens when we go worldwide with this. And it turned out it was going to require 5 times the capacity that the project was originally spec'd at. At that point, it was a business decision. And actually, I can tell you the business decision was, we're not getting enough benefit for this to have to support that much capacity, and they ended up not doing it. In another case, the customer had an application, a customer-facing application, that the app dev team said, we're making a change to it. It's a small change. Customers have requested the ability to see thus and so we're going to make this. We don't see this being a very big change. So they made the change, ran it in test. The capacity group captured the data of that application change running in test, compared it to the application profile of the current application version, and they modeled what happens if these kinds of changes hit our current production versions at the levels that they're running. And they found that it was a substantial impact. And they went back to the app dev team, showed the data. The app dev team agreed to go back and look at it, and they were actually able to tune the code to reduce the impact that it would have had. So looking at application changes, since we know they're happening much more rapidly than they have been, that's a key activity that we can involve. And another way that capacity management supports meeting the objectives goals has to do with test driving tuning options. Now, sometimes people will say, I never thought about that. But it's possible to evaluate tuning options to model, okay, what if we did this in an effort to fix problem X, and to see the results and see that if we're looking at alternatives A, B, and C, maybe alternative B provides the best result with the least effort. Now, disaster recovery, as I noted in the Society for Information Management survey, DR and resilience was the #2 most personally troublesome issue to those executives. Disaster recovery is something that capacity planning using a modeling approach can do very effectively. So you've got your production systems, you've got a model of all of the work, and then you say, we have spec'd, or we have provisioned capacity for backup and this much. Let's start moving the critical work onto that system. And A, let's see if we've got enough capacity, and B, let's see what level of service we'd be providing. And you can do a regular, like a quarterly checkup with this approach that says, are we provisioned sufficiently for a disaster recovery scenario? Now, that doesn't replace a live DR exercise. You still have to make sure that the people and the processes and everything move. And I might make a note about that. This is just a side note. BMC is headquartered in Houston. We're in a 22-story building on the Houston Beltway. The building had a problem. There was a water leak. That water leak was sufficient to create an electrical problem that actually shut down the building. for a whole bunch of days. Now, we run our data center from that building. The data center is not located there. It's actually located somewhere else in the country, not prone to hurricanes, for example. But at the point where the building management said, okay, everybody has to leave now, there's some amount of danger, we need to get this under control, our operations group was able to transfer control to one of their employees running at home from a home office, and using a solution we happen to have ourselves called Mainview Console Management, they began running the data center from that guy's home and then from the homes of several of our staff, and there was no hiccup. Nobody noticed that anything had changed other than the people who had to leave the building. So, side note on disaster recovery and being prepared, because you never know when those kinds of things will happen. M&A happens in organizations, and one of the questions that comes up is how do we process the work of the combined companies? Are we going to add it to our existing applications, or are we going to co-process multiple applications? And those are questions that can be answered, as well as the questions of data center consolidation or decentralization and downsizing. So all of these are the types of what-ifs that capacity management wants to be able to deal with. The key is to be able to predict the service that's going to be delivered, typically in terms of response times, as well as the capacity that's needed, the utilization. And that means dealing with some collateral effects. The mainframe is a complex system. It's beautiful, and it's beautifully complex. And it means that a change one place can have consequential impacts that actually aren't anticipated. And sometimes they've caused us to raise our eyebrows and shake our heads and say, how in the world did that happen over there when all I changed was something way over here? But the fact is, that's the way the mainframe works. So being able to predict the impact of those changes that I just talked about, even something as simple as hardware or as a workload growth, becomes an exercise in understanding all of the complexity of the mainframe. So to predict the impact of change and collateral effects, for example, in this case, there was growth on a workload. It was a high priority online workload, not a lot of growth. And as you can see from those red numbers, those are indexes. Rather than trying to remember what the response time was, it just keeps an index. And it says response time went to 1.02. So we had a 2% response time degradation, which the business concluded was acceptable for what they were doing. But what happened is another workload down here at the bottom saw a 34% degradation. Now it's a batch workload. The business then has to decide, can we accept that, or do we have to make some changes to improve the service that we're delivering there? The first thought generally goes to, well, we need to add some more processing capacity so the batch work can get done. But in this case, looking at the detail, the third column shows the change in the I/O response to the workload. So by being able to see all of the details of what's going on inside the mainframe as part of this view, we understand that the biggest impact was on I/O. So a CPU upgrade is not likely to fix the problem. And as a matter of fact, when they drilled in more detail, the graph shows where the time was being spent on that workload that was impacted. And you can see the big yellow part is waiting on I/O. The issue turned out to be specifically some tape drives. So a CPU upgrade wasn't the right thing to do, but tape drives might have been the right thing to do. But then there's going to be more growth. So this is where we get into how do we deal with all of these changes? You package them with multiple scenarios. So in this case, the bar on the left is the current response time service delivery for that application. And then we look at some tuning options. What if we move that to a different LPAR? So the next green bar is, I moved it to another LPAR. It got a little better. Then we look at the tape drive upgrade. Well, that gets a lot better. That's the next green bar from the left. And then the 4 blue bars say, now let's apply the continuing growth that we expect to see over the next quarters. And once again, the response time starts to climb up. We say, well, how would that have been if we had put it on that other LPAR? It didn't get a whole lot better. But if we do the tape drive upgrade, we see that we've got response time at about the same place it is now after 4 quarters of growth. So now we build a scenario and case to talk to the business and say the hardware upgrade isn't a short-term fix. It actually is going to accommodate the growth that we're looking at over time. So when we have uncertainty, if we can lay out multiple scenarios, you can use the same approach. For example, if the business forecast comes in and it's plus or minus 100%. Because of volatility, we don't know what it might be. So with a given forecast, you run the scenario. What's it look like with that set of growth? Then you try 50% higher and 50% lower, and then you try 100% higher and 100% lower. And you now build a band of results that show with one forecast, you've got enough capacity to last for a certain period of time. With another forecast, you need an upgrade much sooner. And this is the point where it becomes a business decision. Whose forecast is the one the business wants to build the plan on? Because there's so much data and so much change in the mainframe environment, we have to figure out a way to simplify the complexity. One of the ways to do that is the combination of machine learning and analytics with graphics. I know these look small, but part of putting them small was because the story, I think, is obvious. On the left-hand side, that's showing a bunch of work on a system over a 7-day period. And you'll notice the areas in red. So those are color-coded based on what's normal and what's not normal. So using machine learning and the analytics, we understand what's normal for the environment. And we see a system having consistent not normal. That's the red. And if we drill down, and if you have a copy of these, you can see more detail. The bottom line, where there's reds and yellows, that's DB2. It's a specific DB2. So in one picture and one set of graphics, we're focused in on a specific problem area. On the right-hand side, that's kind of a similar idea. Let's take metrics, let's analyze them using machine learning to know what's normal. But in this case, this is portraying a stream of batch work. So it's a group of batch jobs that may be doing, for example, a billing cycle. And it shows the start and stop time of each job, and then color coding based on the metric we're looking at to know where the hot spots or where the delays might be causing us to miss the batch window. Again, analytics, machine learning combined with graphics, let us see the picture. I mentioned the ability to look at container pricing. So I want to take you through a quick example of that. First, the disclaimer. These are examples. The actual specific costs and the way it works in your environment should be available to you from your IBM representative. Please see them to get the details on it. But for this environment, so we're looking at some data from a BMC product called Cost Analyzer, which analyzes MLC costs and allows some what ifs and some reporting on that. So we're looking at a CPC, and the circled area at the top, that's the peak 4-hour rolling average for the CPC. And the colored bars at the bottom are the 2 LPARs that will run dev test. So now we say, what if we put the dev test LPARs in a dev test container, and they no longer impact the MLC. So in Cost Analyzer, we're able to say, what if that happened, and what's the difference? Well, the difference in cost is about, if we look first at the cost before, you see the $400,000 in MLC monthly costs. And then we say, what if we put dev test LPARs into a container, and the difference is about $20,000 a month. And that's the MLC impact. Now, that doesn't include the cost of dev test in those containers, but we're looking at the MLC impact on all the other work. So if our dev test container is allowed to grow without incurring impact or additional cost, what if it grew 3 times? And this takes a look at the cost, the MLC monthly cost, if there were 3 times dev test growth and no container, and no growth assumed on the other systems. So the net is about $60,000 a month increase after 3 years. But another thing we can look at is the dev test after 3 years of growth is going to be consuming, as you can see, 500 to 600 MSUs during the peaks. If we tuned the dev test work prior to going to a container and then allow the growth, the difference is about 200 MSUs. So before jumping into the container, before going to country multiplex, before going to any licensing model, generally it's true that if we tune the work that's going on to reduce the MLC prior to that, we can save money. And one of the ways to make sure it stays on track is with a dashboard. So in the case of MLC costs, this is a dashboard looking at the contract life, looking at projected. So the hashed bars are projected MLC costs, and we can see what's expected over the life of the contract and whether we're going to end up above cost or below cost, and whether we need to make some corrective action. There are some additional capacity questions if you're going to containers. The obvious one, do you have enough capacity for 3x growth? If not, when will it need additional capacity and how much? But more importantly, maybe, what is the impact of that dev test growth on the performance of all the other workloads? And depending upon your environment, shared processor, shared DASD, the complex interconnect effects where we think, well, I've got dev test isolated, there won't be any effect. That may be true, but we may be surprised to find that there is some impact. You can apply that same kind of question to new technologies like pervasive encryption. IBM has stated that the overhead on a Z14 is relatively low single digits, so think 2 to 3%. So the question then for capacity planning is, what would happen if I added 2 to 3% on all of my critical business applications that would be using that encrypted data? The other question is, will we see 2 to 3% in our environment? And they've also noted at IBM that on a Z13 or other technologies, the overhead could be substantially more. But in IBM's Red Book on getting started with ZOS dataset encryption, they note if the CPU cost of converting to encrypted data is a concern, consider the use of an estimation tool to evaluate the potential CPU effect for the application. And as I noted, below is the quote that talks about the overhead on a Z14 versus other platforms. So pervasive encryption still is an amazing thing. Can help put the lockbox around the corporate data. We just have to understand what does that take in terms of capacity to support it. So if you wanted to have a checklist, I provided this think about these things if you want to have your capacity management set up for handling the perfect storm and dealing with the digital disruption that we're encountering. You need to get up and running and implement quickly. Use automation everywhere because we don't have the time, and in some cases we don't have the skills to be manually doing these things. Machine learning and analytics is the way to keep up with the accelerated pace of change. And then using scenarios, predicting service levels, getting aligned with the business by focusing on business applications and not technology. All of these things will put you in a position so that capacity management can fulfill its obligation to the organization. So the examples I've shared, we're done with a couple of BMC solutions. So the message from our sponsor, capacity management for mainframes, and the cost analyzer for Z Enterprise, which is the components that looks at MLC costs. They're designed to help you plan and manage the IT resource capacity, the performance, and the MLC costs in a timely, cost-efficient, and sustainable manner. And if you do that, this is what capacity management ought to provide to the organization. To reduce risk, ensure you meet your service commitments, control costs, deliver value to the business, and actually increase the manageability of the mainframe. So at this point, we have time for a few questions.
Great, Jay, and we do have some questions coming in. So let's start with this one. Does the system learning have the ability to set a new normal automatically after a specified period of time or some known change anticipated in the system?
It's a great question, and it's not just a great question, but you're thinking about what's needed, and the answer is yes. To be effective, system learning has to constantly update the data because what was normal even 6 months ago probably is not normal now. So yes, it does do that, and yes, it really is required.
Here's someone kind of looking for your input on what a normal capacity planning horizon might look like. For example, would you look forward 3 months, 6 months, a year?
So I think the answer to that depends on the organization. Capacity planning needs to tie directly to the organization planning process. So what's the time horizon for the business planning? It might be 3 months. That sounds a little short, but they might have very detailed plans for a 3-month period. They might have less detailed plans for longer periods. So whatever planning horizon the business is using, I would think you'd want to align capacity management with that kind of planning horizon.
Gotcha. Well, here's one. I'm going to see if you agree with this first part. People don't seem to be doing predictive modeling as much today as they have in the past. Why not? Do you agree with that statement?
I think I do agree with it. I think it's partly perception. In the past, and I have a background that goes way into the past on this. So the days of analytical modeling, we ran on ISPF screens. So in those days, you really had to understand modeling, and you had to understand a little bit of the math behind it, and had to know how to manipulate the data through the screens and get to the answer. So I think there's a perception that analytic modeling takes too much time and effort. I think solutions advanced, well, I know this isn't a thing. Solutions advanced. So for example, in the capacity management for mainframe solutions, it automatically builds models for every hour of the day and pushes them down to be stored on the console in case somebody needs to go look at a model. The machine learning of what's normal is just enormously beneficial in capacity management because one of the challenges has always been, if I'm going to build a model, how do I pick the right intervals? Well, now machine learning helps us understand what a normal interval looks like, and the ability to automatically execute a whole series of scenarios lets me not rely on picking that one interval, because I can try it against multiple intervals and see how much sensitivity there is to which interval I picked. So it's a perception. I think it's a perception issue combined with skills. So there's a whole new generation of people that are probably more comfortable with picking up a tool in the PC and using that to try to build the capacity plan, rather than trying to code a bunch of SAS code and generate some trends and reports.
Okay, kind of getting short on time, so I just want to let folks know if we do not get to your question today, someone will reach out to you via email to get you an answer. But I do want to get to some of these. So how much work is it for me to tell your solution all about my hardware, devices, and applications?
In the case of our solution, it's almost no work. It acquires all of the almost all, I'll qualify that. It acquires almost all of the information automatically on the software and the hardware, how things are interacting, what's going on in the system. Customers do have to specify their specific applications, but that's just from a starting point. They just have to say, here's this application that starts here, and we'll go find what technology pieces go with that, so that we can build the application understanding for the customer.
Okay, and this is kind of a follow-up, I think. How does reporting work on your solution? So is it just green screen-based graphics, or can you share them, share the reports?
So the answer to that, I'll try to make a simple answer that really should be more complex. But within the system, it's possible to see a number of tabular reports and graphics. Also within the system is the ability to package together reports in a repeatable package that can automatically then be repeated and, for example, published on a web page. So many of our customers have a process that automatically generates reports, publishes them to an internal web page, and everybody in the organization knows I can go there to see performance and capacity information.
Great. Well, unfortunately, we have run out of time for today, so I do want to thank everyone for attending today's webinar, and I especially want to thank you, Jay, for sharing your expertise with everyone today. Later this week, watch for a follow-up email. It will contain a link to the recording of today's webinar. So that concludes our webinar. Thanks again, and have a great day.
Good. Thank you.